Alright, today we're going to talk about Chapter 4 of Section 4.34.4 again, and today we're going to talk about factoring using the box method. So let's talk quick about what it means to factor again. So remember, factoring, that's when we're pulling out our greatest common factor from all of our pieces. So we're pulling it apart to see what numbers multiply or what polynomials multiply to get you that polynomial. Our greatest common factor, remember, that's what each piece has in common, each factor that each of those monomials within the polynomial have in common. And the box, remember what we're doing when we're looking for the box is we're looking for, or we're going to use something that looks like this. So for the most ones that we're going to do in this class, we're going to use 2x2 boxes. So let's show you guys how we factor this. So what it means to factor is I want to know what polynomials multiply to get me 5x squared plus 16x plus 3. So what I need to do is I'm going to use the box here, and what I need to do is first is I need to pull this 5x squared, is I'm going to put that right in my top left, and I'm always going to take my coefficient, or sorry, not my coefficient, my constant, and put it in my bottom right. So my leading coefficient and variable are going to go in the top left box, and my constant's going to go in my bottom right box. Now what I need to look at is I need to figure out what I'm going to put in those other two boxes. And how I figure that out is I take my a times my c, remember using standard form for quadratics, ax squared plus bx plus c. So I'm going to take my leading coefficient times my constant. Well, that's going to be 15. And we're going to look for two numbers that multiply to equal 15, but we also are going to look for two numbers that add to equal this middle number 16. So now what I'm going to do is I'm going to list out all my multiples of 15. Well, we have 1 and 15, 2 and nothing works, so 3 and 5 works. Let's see what else. That's all that multiplies there. So now we have to look at which one of those multiples adds up to 16. Well, it's pretty easy to see that it's 1 and 15. 1 times 15 equals 15, and 1 plus 15 equals 16x. So I'm going to put those in my box here. Now what I'm going to do is I'm going to look at each piece and I'm going to figure out the greatest common factor of each piece. So what that means is I'm going to look at this part right there. So I'm going to look at 5x squared and 15x. What's my greatest common factor there? And I'm going vertically, so I'm going to write it above, and we can see that my greatest common factor of those is 5x. And again, I wrote it above because of the fact that I went vertically. Now I'm going to try that again, and I'm going to look at 1x and 3. Well, the greatest common factor there is 1. I don't have anything in common there besides 1. The lowest you can ever go is 1 is being your greatest common factor. Now I'm going to look horizontally, so 5x squared and 1x. Well, they each have an x in common with each other. So I know I'm going to put an x down on the side. Now one more time, I'm going to do that last piece right there. 15x and 3, my greatest common factor there is 3. So now what I really factor this out to be is 5x plus 1 times x plus 3. Now I'm going to go on to another slide here, and I'm going to show you that that truly does expand out to get you 5x squared plus 16x plus 3. So now if you remember from the previous videos, when we're expanding these out, I'm going to multiply each piece by each piece. So we get 5x squared plus 15x plus 1x plus 3. Now combine our like terms and we get 5x squared plus 16x plus 3. Notice that I got the same thing. So really when I'm factoring, I'm finding the polynomials, the two monomial polynomials, so the binomials that multiply to make me the trinomials, a three-piece polynomial. So let's show you another example here. Again, we're going to take that first piece and we're going to put that automatically in the top. So 3x squared goes down there, and the last piece always goes in the bottom right. Now what we need to look at is, okay, what number multiplies to get us, well, what's 3 times 8 first? That is going to be what number multiplies to get us 3 times 8 is 24. So what multiplies to get 24, but then adds to get you this middle number, which is a negative 10. Now we have to look at is, well, it's a negative number. So that means both the numbers, and well, it's a negative number that they add to and they multiply to a positive number. What kind of numbers do that? Both negative or both positive are going to multiply to get a positive number. And since they're adding to get a negative number, they both have to be negative. So I'm going to look at all my possible multiples of 24. We have 1 and 24. We have 2 and 12, 3 and 8, 4 and 6. And that's all we have. Now we know both of them have to be negative. Negative, 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 negative. Which ones add to get negative 10? Well, it's negative 4 and negative 6. Negative 4, negative 6. So I'm going to plug those back in. Negative 4x, negative 6x. And again, I'm going to look vertically at each piece. So I'm going to look first here. What's my greatest common factor? Well, it's going to be a positive 3x. And again, we want to look right here. What's our greatest common factor? Well, now this is the trickier part. Since we're going up, we're going to use that negative 4x. That negative in front of that is going to be, we know it's got to be a negative number. So we know right now it's a negative number, and we know that if we look at 4x and 8, it'd be a positive 4. So our actual greatest common factor is negative 4x. And again, we're going to go and we're going to look at this piece right, oops, forgot to hit my pen. This piece right here, what's my greatest common factor? Well, it's just an x. So it's just an x. And then one more time, we need to look at this piece. What's my greatest common factor? Again, since that negative 6 is in front there, is our leading piece, the negative 6x, so it's going to be a negative number. And our greatest common factor there is going to be negative 2. So that means that our multiples, our factors of this are going to be 3x minus 4 and x minus 2. I'm going to do some more examples that hopefully help you guys solidify this. I know it's a little bit difficult the first time you see it. So let's try some other ones here. Well, what we need to look at, again, I'm going to pull the box over here. I'm going to fill in the pieces we know. We know that the top left is g squared. We know that the bottom right is negative 24. Now really in front of that g squared is a 1, so we need to look, okay, what numbers multiply to get 1 times negative 24 is negative 24. So what multiplies to get negative 24, and what adds to get our center number there, which is a positive 12 or positive 10. Now again, we have to look at this. We're multiplying to get a negative number, so we know it can't be positive, positive, or negative, negative. One has to be positive, one has to be negative. And it adds to get us positive 10. So we know that the larger number itself is going to be positive. So let's figure this out. We get 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Now if we make each of these positive or each of them negative and add them together, the only ones that are going to work are 2 and 12, with negative 2, positive 12, negative 2, positive 12. Add those together, they'll equal 10. Multiply them, they'll equal negative 24. So negative 2x and positive 12x. Now again, we go and we pull out our greatest common factor of each piece. Sorry, these aren't x's. These should be g's. I don't know why I made them x's. So negative 2g and positive 12g. Yep, I flipped them around. Sorry about that. Now we're going to do our greatest common factor from each piece. So going vertically here, g squared and negative 2g is going to be g. 12g and negative 24, since my leading one is 12, positive 12, it's going to be a positive number of positive 12. Now we're going to go left to right. So g squared and positive 12g, that's going to be g. Negative 2g and negative 24, well, they're both negative, so that one's easy to see. That's negative 2. So our factored version of this is g plus 12 times g minus 2. All right, now let's try a trickier one where we're not given that center number. If we're not given that number, we can rewrite this to be 3a squared minus 0a, or plus 0a, it doesn't really matter, minus 300. So we have to look at what numbers multiply to get you 3 times negative 300. So let's pull our box here. So multiply to equal negative 900, but then add to equal 0. So what do we know? If they add to equal 0, they're going to be opposite numbers. So what numbers multiply to get by itself, but the opposite to get you 900? Well, 30 times 30 would get you 900. Make one of those negative and we'll get to 0. Positive 30 and negative 30 plus positive 30 is going to equal 0. So now again, let's fill in our pieces. Our leading part goes into the top left. Our constant goes into the bottom right. Now we fill in with our pieces over there, negative 30x, or sorry, negative 30a, and positive 30a. Now we pull out our greatest common factors going vertically. We'll have 3a. We'll have a negative number because our top number is negative, and it'll be negative 30. Go left to right, we'll get negative, or positive 3a again, and left to right again, we'll get positive 30. So our greatest common factors here are going to be, it's going to be 30 or 3a minus 30a times 3a plus 30a. Now let's check if we did this right. So let's expand each piece out. So we'll get 9a squared plus 90a minus 90a minus 900. So we combine our like terms, we'll get 9a squared minus 900. Is that what we started with? Well, no, it's not. So we made a mistake. And I'll tell you exactly where we made a mistake. And I made this mistake on purpose so everybody would see why you have to do this first. We need to erase this whole thing and start over. Because what we need to do first is we need to do our greatest common factor. Biggest mistake that people make when factoring is not pulling out the greatest common factor first. So our greatest common factor of these is going to be 3. So it's really going to be a squared minus 100. Now we do the same exact stuff that we just did down there. So we do, okay, really this is the same thing as a squared plus 0a minus 100. So what multiplies to equal negative 100, but adds to equal 0? Again, these need to be opposites. So it needs to be 10 and negative 10. So 10, negative 10, 10, negative 10. Those will add up to get you 0 and multiply to get you negative 100. Fill in our pieces with what we have is really a squared negative 100. And we have positive 10a, negative 10a. Pull out our greatest common factors. We have a, negative 10, a, positive 10. Now we're going to have our greatest common factor is a minus 10 times a plus 10, and we're done. Oh wait, no we're not. Don't forget to bring back down your 3. This is our correct, fully factored version. Do not forget to pull out your greatest common factor first. Yes, I did that on purpose so you guys would see that. I apologize if you wrote it all out and had to erase it and you're sitting at home being angry right now. All right, let's do another example here and then I'll do some problems that you guys can do. I'll put up some problems you guys can do. So first thing, let's look for a greatest common factor. Greatest common factor of these is going to be 4. So we have 2m squared plus 7m minus 30. So now we look on the inside. What numbers multiply to equal negative 60, but then add to equal 7? Or if they're multiplying to be a negative number, we know that they need to be one positive, one negative. If they're adding to be a positive number, we know that the bigger number. I'm going to do this one for you because it's going to be 12 and negative 5, 12 and negative 5, not negative 15, negative 5. Now I'm going to bring down my box and I'm going to use that to pull my greatest common factors. So I'm going to fill in the pieces again with 2m squared, negative 30 go inside there. Then I'm going to pull my other 2 over here. So 12m and negative 5m. Pull out my greatest common factors, 12m squared and negative 5m. Well, the greatest common factor is m. 12m and negative 30, that's going to be 6. 12m and 2m squared is going to be 2m. Negative 5m and negative 30 will be negative 5. So my my factors are m plus 6, 2m minus 5. We're not going to be a bonehead this time. We're going to remember our 4 and bring it on down. And there's our our factored version of this problem. Now I know I said I was going to let you guys do a problem, but first I want to do this one problem and show you guys how to do it. Because what we're starting with now, which is different, is a negative x squared. And whenever I have a negative x squared out there, I want to get rid of that negative. So I'm going to factor out a negative 1 from each number. So really it's going to be negative 1 times x squared minus 8x plus 12. I always want my polynomial to be a positive leading coefficient to factor them. So I want my trinomial to always be a positive number. So now I can look at the inside here and I'm going to do my factors. So I'm going to 1 times 12, well that's going to be 12, so it multiplies to get you 12, but it adds to get you negative 8. Well, right there it's kind of tricky. It's multiplying to get a positive number, but adding to get a negative number. Well, if it's positive, it needs to, multiplying to get a positive number, it needs to be both positive or both negative. So I know they're going to both be negative if they add to get you negative 8. So negative 6 and negative 2. Now we're going to bring over our box, fill in our pieces. So we have x squared up on the top left, positive 12 on the bottom right, negative 6x here, negative 2x here. Factor out x squared and negative 2x is going to be x. Negative 6x and positive 12 is going to be negative 6. X squared and negative 6x is x. Negative 2x and positive 12 is going to be negative 2. Remember, the leading boxes are what we're going to use our positive or negative from. So really we have x minus 6 times x minus 2. And don't forget to bring down your negative. All right. I'm going to do 2 more examples, then I'm going to put up ones for you guys to do. So again, we can rewrite this one as 36x squared plus 0x minus 1, so we can make sure we realize that they need to do that. So we know they need to multiply. We do our leading coefficient by our constant. They need to multiply to equal negative 36, so they're multiplying to be a negative. One's positive, one's negative. They're adding to equal 0. All right, well the numbers that do that are 6 and negative 6. All right, let's bring over our box. And we'll have 36x squared. We'll have negative 1, 6x, negative 6x. Greatest common factor is going to be 6x, 1, 6x, negative 1. So really this is going to end up being 6x minus 1 times 6x plus 1. So it can get pretty quick after you guys get a hang of it. Again, let's do this one. Don't have any greatest common factors, so I multiply. 6 times negative 15 is going to get us negative 90. So times to get us negative 90, and we need to add to equal 1. So again, if it multiplies to get a negative number, we know that it has to be both one positive, one negative. The bigger number is positive because it adds to get a positive, so it's 10 and negative 9. 10 and negative 9. You can list out the factors if you guys can't find them that easily, that's okay. List out the multiples that get you negative 90 and see which ones add to get you 1, with one of them being negative. Pull down our pieces, 6x squared, negative 15. Put in our parts that we figured out. Pull out our greatest common factors. 6x squared and negative 9x is going to be 3x. 10x and negative 15 is going to be a positive 5. 6x and 10x is going to be 2x. And negative 9x and negative 15 will be negative 3. So it'll be 3x plus 5 times 2x minus 3. All right, let's give you guys a chance to try some of these. So I want you guys to try these 2 problems. I'll put up the answers here in 1 second. All right, I gave you guys a trick question for that first one, 2w squared plus w plus 3. That's not factorable because I need to multiply to get 6 but add to get 1. There's nothing that can do that, so it's not factorable. And what we call that, what's not factorable, is a prime factor. So a prime polynomial, sorry. So this is prime, not factorable. Sorry we spent a lot of time on that one. I did do that to trick you guys. The second one there, you guys can see the answer to that one. Now I want you guys to try another one on your own. I want you to try this guy. All right, here's the answer to that problem. All right, if you guys printed out the notes, I have a lot more examples that you guys can go over. Check your work. Make sure you pull out greatest common factors first. Always pull out your greatest common factors. Then multiply your leading coefficient by your constant, and it needs to add to your B value, that middle value. So I left a lot on here that I'm not going to go over just because of time's sake. So try them on your own. Let me know if you have any questions. Go slower on that if anybody wants to try them that didn't print out the notes. Try these problems. Let me know if you have questions.